I think it's time to kick off another video related to some of the threat modeling in Google Kubernetes Engine, but broadly speaking to illustrate some areas that you should be aware of when adopting Google Kubernetes, right? While this is a larger topic, right, to break down a lot of nuances, I'll try to keep this quick to the point, but at a high level, and then I can also add these to my description if these really help you out. So I'm going to zoom in. We'll talk about some of these items here that I created before this video to prep. So what you should be seeing is essentially our auth in and auth c. You'll hear this commonly referred to as what are you doing with auth in, auth c. So to dispel this in two ways, you want to think about authorization resides in Google Cloud predominantly. Oh, it looks like my looks like I have a sensitive eraser. Let me just double erase that there. Let me refocus this area here. So we have what is known as our authentication, right? Essentially the user, and then we have the permissions, that's our auth-c. So you want to think about this at a high level as, let me see if I can get my writing right. Okay, that's not looking too hot. All right, well, I tried the pencil approach. I guess that one won't work for this video. No worries. Let me disconnect this in the background. So let me erase this real quick. We'll erase this. And we'll just go with the old tools that we already got. Okay, no worries. So catching back to where we left off, let's not miss a step. Auth in, auth c. So plainly speaking, when we create an account, what essentially are the accounts that we are going to allow to do certain operations in our cluster, right? Now, this is going to be highly dependent on how you configure the cluster to operate, right? So you want to think about how does Google Cloud approach auth in, auth c, specifically for Kubernetes Engine, right? Most of these wrappers, per se, on top of the control plane are going to encompass a lot of this nuance that you want to break through. So I try to summarize this quickly for you. You want to think about, you have two types of accounts. Generally speaking, you have your Google account, you have your Google Cloud Service account. Now you want to think about a service account similar to how in Azure has a service principal, right? Essentially that's going to be, this could be for acting on behalf of a user or a application, right? So a key concept, you want to always monitor the service accounts that you are assigning to ensure they're not default type of permissions. A prime example that Google Cloud, a lot of people that aren't familiar with Google Cloud Platform is reliance on using the Compute Engine service account, which essentially allows it to read and write to the API. This is well known, right? These are things that I want you to be aware of as you adopt this service, regardless of what cloud you choose, but some things to be aware of at a high level, right? So the Google accounts give you access to services that you're already familiar with, such as Google Mail, right? A free service, YouTube, and then applications, plainly speaking, if you're an Android user. Now, the Google Cloud Service accounts exclusively will sit in the cloud service provider, right? They're going to sit inside typically a project. So hopefully this is not your intro to Google Cloud, but we can break down that a little clearly. So you want to think about similar to how AWS, Azure operate, the structure of Google has a little bit of different nuances. So they have this concept of, you have your organization, right? And you will have these projects that sit throughout your organization, similar to how Azure approaches subscriptions, right? So in a perfect world, these will be children of the main type of organization, or the root per se. So this could be development, and development has all the operations centered around their developers, right? Staging, whatever the case may be, if they have a separate entity for that. But typically you always want a bottleneck, and if you see me interacting with this, that is why. You want essentially some type of second level abstraction. And this specific organization up here will sit on its own. And the reason being is when we orchestrate our policies down to a specific subfolder or folder for that key details, right? This can be, you can think of this plainly speaking as corporate. Now, I'm not saying this is the approach I see in practice. However, this is a best practice, okay? I always will delineate what I consider a better practice. And hopefully, this is something you're following as you adopt, right? Now, broadly, you want to understand this concept of, you'll hear blast radius, right? Now, blast radius, plainly speaking, from a zero trust perspective, will essentially say, instead of having lateral access across our organization, right? So if I compromise a domain admin, and then I have carte blanche across the organization, right? You want to create these layers in between other aspects of your organization. That's really the concept of when we're thinking about cloud security at a high level, orchestrating what that architecture looks like, but also B, the in practice why the practicality is there, right? So sorry, this took me quite some time. So we will run production here, right? And then we will push out policies typically from this parent, if you will, corporate. Sorry, it's just been a long day. Specifically, so you will see this similar to how this looks right here. Now, the reason being you want to cover the differences of the nuances is because for organizations at the Google Cloud level, these are essentially going to be domain controlled, or if you will, how to create an organization is a big portion. If you're already a Google Workspace, i.e. productivity suite, plainly speaking, user, then this shouldn't be nuanced. But let's say you just adopt Google Cloud as an organization from an IaaS perspective, right? PaaS, etc. You will have to create an organization and create essentially a account separate from your traditional. So if we're testing certain type of features in Google Cloud, right, and we're using our own personal.gmail, that's not the use for this, right? This will be like at Roger Tech or whatever the case may be, and then I got to validate I have ownership of that domain, right? There's a whole process for that. I won't be covering that, but in general, just a quick overview. So now when we go back to understanding, okay, if we know that Google accounts essentially can operate multiple services, right? And Google service accounts are a little bit more constrained, but they're also dependent on the permissions we give it. So a couple of key features that stand out, or what's a differentiator in Google Kubernetes Engine. So I created this image up here, hopefully, when my pencil was writing a little bit. The binary authorization. So that is this logo right here. This is native to Google Cloud, and I would say it's a differentiator. And it is a way to essentially attest specifically of policies that you put in place on the cluster to validate your software supply chain broadly. So for container images, right, a single source of truth, we want to ensure that those images are scanned, right, particularly automatically on push to the specific private repo, and then some policy set to ensure that it doesn't get promoted to prod, but it's a more tailored approach as far as when it does move to prod, it goes through a check per se, right? And that's really where binary authorization shines. Now, I put together at a high level some of the syntax that you see here using binary authorization. This is a screenshot from the official Terraform documentation. So if you're wondering where that came from, or if it looks familiar, right? So you can see here we're declaring Google binary authorization attester, and then a attester, the name, and then we're putting the note specifically, and then we're referencing our own keys that we're using. Now, mind you, depending on the regulation that your organization is subject to, you likely want to know what type of controls you put in place. Broadly speaking, across AWS, Google Cloud, and Azure, there is components of bring your own key, right, for that higher level of control to your encryption keys. The only drawbacks that you typically see is perhaps the unmanagement of the lifecycle policies. And that's a fairly small trade-off when you think about the large scheme of things, but just something to keep in mind. So typically, the further you go to the customization piece, right, the cloud service provider will provide the underlying support and resources as you are paying them, but there might be some native integrations that I wouldn't say are less secure, but are more dependent on those APIs that are directly managed by the cloud service provider, if that makes sense. So broadly, I wanted to also show how binary authorization looks through YAML, right? So we can see up here, we have to, as we spoke about the projects, right, specifically. So if you see me working through here, and this is just to call out that visual even further. Let me change that to a more vibrant color instead of perhaps green. Or no, so there we go. Yeah, some green right there. So we can see what the cluster admission rules are. We can look at what is the global policy evaluation mode, right? And so, so I tried to attempt and create a cluster. I was running into some issues with some of the resources I did create, but I did want to get this video out, so we will just go as is. So picking back where I left off in the last video, we covered at a high level some of the key areas to consider. That's going to be authentication, auth-in, auth-z. Primarily, we covered the recommendations based on IAM policies, right? You want to think about what you have in place beforehand, before deploying, hopefully, ideally. And then you want to think about B, what does that look like across your enterprise broadly, right, as your organization moves forward. So for GKE specifically, the recommendations at least listed from Google Cloud for a couple roles are listed here. So the Kubernetes Engine cluster viewer, broadly, it states that that's going to be DevOps engineers. And app dev, right, it might be others as well, right? Just viewers as far as that's concerned. Now, the actual operations in managing the cluster, that's going to ensure that that API calls roles container cluster admin, right? That's essentially who managed that. This specific document I linked down here, I know it's not showing the most nice visual format there, but that's one of those key areas you want to consider, right? Now, broadly, IAM is going to be a lot more than that. And that was the key piece that we covered over here, right? So just showing the authorization techniques that Google puts together. They're really good with their documentation on showing what is a good policy, what is not a good policy. Now, a couple areas I don't think is always covered that should require some attention is we should think about broadly, and let me create another category for this. How are we going to gain our visibility, right? And that's going to really be audit logging. I'm not sure. Oh, yes. So this might have left me blank from there. So broadly speaking, when we think about audit logging, right, large picture, we're going to need to understand who is the type of policy that we want to configure or create that is going to reside in our cluster. But we also need to understand the way that logging operates from a managed cloud service provider instance, right? So broadly, the way you have audit logs available to you is you have admin activity, right? And this is essentially who can do what right, primarily. And this will coincide with some of the metadata operations. And then you also will have another, what I call umbrella to that specifically. And that's going to be down here. And I'll change this color to maybe blue. Then you want to look at data access, audit logs. Now, for GK specifically, there is two types of different logs, right? The admin activity, think of that, the who did what, the right. And then they're very keen on data security as far as who has access to that data, right? Now, this includes just read operations, data read, data write, but just at a high level. So you want to think about how that essentially translates. So broadly, they provide a reference, and I'm just referencing this, okay? So this should look like container security, v1 beta, container security, search cluster finding summaries. So data pertaining to that area, right? So broadly, let me put that there, and then we'll add another to that. And this will also look like Google Cloud Container Security, v1 beta, container security, list findings. Now remember, list in general enumeration. I probably spelled that wrong. I feel like I spelled that wrong. Perhaps not. Anyways, and the audit activities are going to essentially allow you to gain access to what is going on inside your cluster. Now, a key note to understand about logging, specifically to Kubernetes, is it adds up fairly quickly. And I'm not saying that to diminish the visibility that you input to audit logging, right, for your organization, because audit logs should be fed ideally to some form of log aggregation, hopefully some type of seam. Now, there's going to be specific areas you want to pay attention to in volume, right? The control plane itself has a number of areas that you want to be concerned about. Now, I will put this specific audit logs documentation in the description, but they also do provide, Google does provide some actual resources, some queries to use some of their native log explorers. So if you circle back up here, you should be familiar with cloud logging inside the cloud or log explorer, right? And essentially this allows you to query some of your logs visually in a nice format. And I'll show also how that looks. Let me switch over to a different one. So let's see here. Let me change views real quick to something that doesn't show that. Windows capture, let's do a Chrome. Sorry about the difficulties. I've been having a lot of issues today recording, but I wanted to get this out. Okay, so you should be seeing now what the control plane, if you will, inside the console experience is, right? So this should look familiar. I've done some more videos on GK specifically. But this essentially will house your resources associated with using that service, right? So similar to how the control plane looks in Azure, when I go into the portal, I'll have my workloads, my clusters, right? And then a list of clusters to grab my credentials as needed. I have deleted a cluster, but some of those key areas that I talk about for node access, right? So similarly to AWS, Azure, they're always going to recommend keeping the cluster admin or the cluster API control plane obfuscated, not on the public web. So what does that mean? So essentially when I go to create, and I'll show you what that experience looks like. When I create a cluster, I will have a couple options that I should be aware of, unless I'm doing this through autopilot, right? The difference between what you want to think about autopilot, it's almost a full service. They make it pretty turnkey. I'll just show you what this looks like. So this goes through cluster basics. I just give it a name. Let's say cluster operations East US. Now this hardens a lot of the configuration. So I can see what would be next if I want to use it in a fleet, right? You want to think about a fleet, a grouping of clusters in that realm. And then if I want to go to the network, we can see here I have public, private. Ideally, we want to be on private. Now there's some cost associated with this area as well. Now you'll see access control plane using its external IP address. So then we can put disable this option, locks down external access to the cluster control plane. Essentially, I'd have no entrance into the control plane. But this would be fairly secure. But again, this also still tells you there is still an external IP address used by Google Cluster for cluster management purposes, right? But the IP address itself is not accessible for anyone. And if you do this, the setting is permanent, right? Now, again, this doesn't mean, hey, you're shooting yourself in the foot, but this should be aware of before I go through that. So let's say I don't do that. I can also specify the pod range, the service address range, and then let's say I wanted global access to my control plane. Pretty broad, okay, but perhaps my organization operates across multiple geographics and we need to access that, so maybe we want to do something there. Now, notice that this area is grayed out. So the control plane authorized network, this essentially is telling you if you did want to use a authorized network, i.e. Whitelisting your public, private IP to be the only accessible one, or your publicly assigned home network per se, this is that option there. But notice I have to keep it public if I do that. It's just going to whitelist that. So then now this turns gray. So just to show you what that looks like there, and then we'll go to advanced to show you some other key areas here. So as far as automation, I can enable that maintenance window. So similarly, when we talk to upgrading, keeping your environment up to date, now I can specify if I want a weekly type of update or a maintenance window for any type of upgrades needed, right? Obviously, you can see you can get pretty granular with that. Now, if you plan on using Anthos Service Mesh, this can show you specifically if I enable this, what is Service Mesh right now. There is some pricing related to it as well. This is one of those native capabilities that Google Cloud operates, and you can also use Istio as well, so don't feel obligated. Now, as far as security, so the binary authorization is not enabled out of the box. This is something you need to enable. Now, notice there is 3 types of enablements, right? Enforcement, enforcement, or audit only. And then perhaps I want to use Google Groups for some of those native RBAC capabilities. And this is likely called out, I would wager, let me hit learn more. This is likely called out in a CIS benchmark. Primarily, this allows you to get further control of the identity layer by using the native constructs of the IAM from typically the cloud service provider. So this goes through some of that, but I would wager if I looked up the CIS benchmarks for GKE, this would be one of those key recommendations. But it does change some of the operations, so you definitely want to be aware if you do that. Now, the secrets at application layer, you want to go through if I am storing my secrets in a KMS system, that external data store, what are the secrets that are protected and encrypted as far as that? And then configuration auditing, right? So this will tell you what that enablement is. One thing I really do like about GKE, it's fairly straightforward. It's to the point on all their documentation for what you need. And then you can also enable workload vulnerability scanning for some of those native capabilities. Now, again, there's going to show you basic and advanced. This will also tell you some of the requirements, right? So at a high level, and then going into the service accounts, right? So you don't, I won't pre-populate that, but you can have your Google managed encryption key. You can also do your own encryption key, right? And then this can go through, if I don't have one, I can populate it, etc. And then any service accounts related to the cluster that I want to be called. Now, mind you definitely want this defined, okay? And if you can see, we can even go to the granular level of access scopes. Allow default access, that's pretty carte blanche. I would not recommend that. Now, if I can set access for each API, I can go, let's just go with this, so that stops that image there. Okay, but you can see you can go pretty granular on the settings that you want in place, right? So without losing the depth of the conversation, just wanted to show at a high level some of the key aspects related to Google Kubernetes when we're thinking about the underlying components of threat modeling, right? When we address back to our attack tree that we created, these are going to be some of those questions you want to have worked out, but B, you want to be aware of right before you adopt. And if you can see here, I have a similar drawing that I did previously. This shows the service paralysis when we're talking about accessing our cluster from a secure portal, right? That is has SSO, regardless if it lives on-prem, in the cloud, and has RBAC as well. So that's just a demonstration of part of it. Now, I will obviously keep iterating on this, but I wanted to show you at a high level some of the key areas you can start taking advantage of now or at a later date. But to be aware of before we move into operations, what are some of those native constructs I should be aware? So that's where it gets a little different. Each cloud service provider kind of has their ins and outs of how they put out a managed Kubernetes distribution. Luckily, when you do deploy in GKE, they typically have the most recent distribution out upstream. So like if I did, let me go back to the creation phase and just show you, they already are running 1.9 for their cluster. So let me switch to standard so I can get out of this abstracted here. And if you can see, autopilot only gives you 4 options. When I go to standard, the options expand dramatically. So we can see here, right? So some similarities, but a lot more control per se of what you want, customization. So I can go with a regular channel, I can go to stable channel. I can look here for the regular channel that's already supported 1.29, right? But let's say I want rapid channel, right? They already have 1.29.1 in here. So I'd say your benefit is you're closer to the bleeding edge if you want to update consistently. But nonetheless, I probably, as far as production is concerned, most people will stay in a stable channel. So you have something that's a little bit more battle tested, right? But just one of those kind of key details that you'll see. And then similarly, when on the security parameters, I can workload identity, Google groups, right? And then I can specify what those groups are that are a part of the RBAC access. And then, of course, you don't want legacy authorization. It still is a possibility, but I would not recommend that. And then this talks about the metadata aspect too. If there's any metadata that you'd like to have a part of your cluster, you can label that here specifically before the creation. And if you go to features, you can go to your logging. You can see specifically if I'm concerned with the API server, the scheduler, control manager, right, components. Let's say I'm just focused on the API server. This should, I want to say this next one, will say specifically. Okay, so let's say I'm just concerned about my API server and I just want to look at all my pods and deployments and our persistent volume, but realizing everything else that will be missed, right? So you can get pretty tailored metrics with that. And then as you can see, there's a lot more selections here. So hopefully this helps you out, demystify some of the operations, but B, start considering when we're going back to that attack chain. The first step is IAM. Hopefully this next video, I have a live cluster and we'll do some more operations. But I want to move over to AWS as well and address some of those key differentiators, but also how we address the key concept of that attack chain broadly, regardless if that lives in another cloud, etc. Okay. So hopefully this video helped out. If this did help you out in any way, feel free to subscribe, share this content broadly. Thank you for your time.